Okay, so we would like to solve this exercise. We have to draw a graph of an arbitrary function g, which satisfy these conditions. So we have g of 0 is 0, g prime of 1 is more than 1, g prime prime of minus 1 is more than 0, and g prime of 2 is 0. So let's draw these conditions, what it means on this graph. So when x is 0, the y has to be 0. So the graph has to go through this point, 0, 0. This is the first condition. Okay. Then g prime of 1 has to be more than 1. G prime of 1. Okay, so we have to first figure, we don't have any condition on the value of g, so we can put the point whenever we want. Let's say put it here. And then g prime of 1 has to be more than 1, so the declination of this line has to be more than the line y equals to x. So let's say we have a tangent like this, which is steeper than. Okay, so let's say, okay, so the graph is like this. Let's use another color. Okay, so let's the graph of a function goes like this. The tangent line is steeper than for k equals to 1. And then we have another condition, g2 prime of minus 1. That means that is greater than 0. That means that the function here has to be convex, meaning that the tangent line has to be under the graph of the function. So let's again choose a point here, because there is no condition on the value of g, so we can choose the point arbitrary. Let's say we choose it here. Let's draw a tangent line. Okay. Okay, so we have a tangent line, and we know that since the second derivative is greater than 0, that the graph will have to be above the tangent line. So here we have a tangent line, and then the graph would have to be above the tangent line. That's it. And then we have another condition which has to be satisfied. This is at the point x equal to 2. It has to be, the derivative has to be 0. So we have to have a local extrema. Now, since here is increasing, then we will probably have maximum here. So let's see. So here we have a maximum, local maximum. And the tangent line is parallel to the horizontal line, is horizontal. Okay. We can of course write another case which satisfy the same conditions. So we have to go through 0, and let's say here we have 1, and here we have 2, and here we have minus 1. So let's see what happens. So here it has to increase greater than k equals to 1. Here it has to be, the tangent line has to be horizontal, so we have this condition. And here we know that the function has to be above the tangent line. So let's say that we have a tangent line like this, no? Or maybe let's say we have a tangent line like this. Now let's draw the graph of a function which satisfy all these conditions. Okay, so here the graph has to be above the tangent line, then it has to go through 0, 0. Then here it has to increase rapidly, and here it has to have a local extrema. Okay, more or less. Now you can imagine another graphs which satisfy these conditions, but that's basically what you have to do.